All right, with that, we're entering our last session on this full day ISAC online webinar. And our last session will have one presentation on ISAC from the 3GPP perspective, followed by a panel discussion. So I invite Yingyang Li from Xiaomi to present on the 3GPP perspective of ISAC. So please go ahead and share your screen. Thank you.
Hi, Hank. Yeah.
Hi.
I'm very happy to have this chance to give this presentation. So let me share my screen. Okay, wait one moment. So is it okay now?
I see this. Yes, now I see it. It's not in presenter mode, but I see it. Yes, now it's perfect. Thank you.
Okay, yeah. So yeah, as the rapporteur for this study item, channel modeling study item in 3GPP, so I would like to introduce the some progress and also some open issues. We are still under discussion in the meetings. So okay, so yeah, the structure for this presentation actually has four parts. The first part is actually give some overview and also motivation to do this channel modeling. Then the progress and discuss some open issues still discussed in round one. Then the last, I will give some discussion for the future plan in the remaining meetings. Okay. Okay. So start from this motivation. So in 3GPP ICV1, actually, there's some discussion for the potential use cases for the sensing. I think all the people maybe had already know some details. So in general, this 32 use cases is divided into three scenarios: object detection and tracking. So I give three figures here. So it could be some detection for vehicle, for human on the road, and also the UAV, and also maybe the indoor factory. And also there's some other scenario for the indoor home. There's some human, you can try to detect intruder for that. And also some other scenarios, there could be environment monitoring. So for example, there's flood, and also some motion monitoring. For example, this to model this breathing of the human. Yeah, among these 32 use cases, there are many kind of sensing targets. It could be UAV, could be human vehicle, AGV in the factory, could be animal, could be some many other things. And also three kind of sensing modes actually are used in the different scenarios. So I just give some figures. I think everyone can know the user meaning for this instrument. So based on this, so many use cases, so many sensing target, so many sensing modes. So one key thing to start the exact solution design is actually we should have one available channel model. So it is to verify whether when sensing algorithm is acceptable, whether the design of some signals, some procedure is enough to support this purpose. So basically, this means we need the channel modeling for ISAC. So this is the seed from the grid. This in the December last year. And you can see the last line is deleted in red. So this is just happened in September this year. So we have some debate and then decide to for the remaining time of this study, we just focus on the channel modeling. So there's no more work. Okay, so just to give a high level view. The study is from February this year and will end in the June next year. So in total, there are 9 relevant meetings, where the 4 meetings are passed. So we still have remaining 5 meetings. Okay, so also very high level things. So in 3GPP in the TR 3891, so basically 2 channel models are available. The first one is this geometry-based channel model, stochastic channel model. So this one is commonly used in the simulations for the many studies in run 1. So basically, we could say this channel model is quite stable. It will also the complexity is actually acceptable, and many companies already develop the simulators. So such kind of source codes for channel model is well calibrated among companies. Finally, after some discussion, so the people in run 1 we decided to try to do some enhancement for this GBSM channel model. In the TR-3901, there's another channel model, the map-based hybrid channel model. So this one is actually the retracing based. From run discussion, actually, there's some companies propose to do some enhancement for this map-based hybrid channel model. However, I think this is based on the run discussion, this is actually the low priority. Maybe in next year, we will do something for this extension for this retracing channel model, but it's depending on some further agreement from run 1. So maybe at this moment, we cannot guarantee whether this hybrid channel model will be enhanced or not. But anyway, the current old run 1 work is actually focused on enhancement to this GBSM channel model. Okay. Yeah, in the past 4 run meetings, we already made some progress. So in total, after some discussion, the combination level is actually agreed to be 35. We agree on some very high-level direction or high-level design methodology, but still some details relying on some further discussions. So this page is actually focused on the scenario. Based on you can see the table on the upper right. So we have 5 kind of target: UAV, human, and vehicle, AGV, and also in the highway or some railway, there could be some object which will creating some hazard. For example, some goods may just drop from one car. It will cause some hazard to them following cars. So for each sensing target, we already decide the related the reference communication scenario. So basically, you can see that for UAV, it is RMA AV, UMA AV, and UMI AV. And yeah, we will try to define some channel model, and also referring the current design for this kind of communication scenario to get some parameters. But of course, some parameter may be not suitable for sensing. We need to do some validation to check, also try to modify the values. So this kind of discussion is still ongoing. Also, from high level, the run 1 is actually try to do some prioritization about the different scenario sensing mode or targets. However, it's very difficult. So finally, the current discussion scenario is actually we assume all the combination is possible. So we define the common framework. Maybe in the later meetings, we can do some down selection or some prioritization, but yeah, it depending on discussions. So basically, in the last meeting, the current progress is we already make the scenario parameters for the UAV use cases. So in the last bullet, at least several parameters. It's too detailed. Maybe I don't need to spend too much time on this one. But in general, yeah, we have the progress for the UAV. Maybe in the next meeting, next several meetings, we will further discuss the parameters for human, for vehicle, for AGV, for them others. Yeah. So this is the scenario parameters. This part is more key part for the channel modeling. So it is the details regarding the channel model. In general, the framework is the ISAC channel model we agreed to has, in general, it has 2 parts. two components: the H target, the target channel. It is some signal from the transmitter interact with the target, then go to the receiver. And also the background channel. That is something not go through this target. We also make a high-level agreement is, so we will model the unlost component, the non-line offset signals. This one can be modeled by stochastic cluster, and also this one is actually similar to the current TR-901. It is just randomly generated some clusters. We will also model a kind of environment object, but this EO, we just emphasize this is something has some known location or known characteristic. So basically, we can use some deterministic method to model the signals to or from this EO. So far, we have discussed two kinds of EO. So EO type 1 is something maybe in the similar shape, similar size to the setting target. So currently, we list EO type 1 as the separate things, but it may be possible later, because it's actually quite similar to target, it's possible it can be handled as if a target to just save some effort to the channel model discussion. For EO type 2 is kind of, the example is ground, the wall, the ceiling. So basically it means a very large environment object. So we agree to model specular reflection for this one. But some other details is still ongoing. For example, for wall, for ceiling, it actually has some limited size. And also some company also will also discuss, we agree to model this specular reflection, but it's possible maybe some other scattering for the signals could be also modeled, depending on some further agreement. So this is the channel model, and also for the target object model. So mainly this means this RCS modeling. So this target or this object could have single scattering point or multiple scattering point. Yeah, I have two figures here. So for UAV, normally it's of small size. It's also the UAV maybe in high skies far from the transmitter receiver. Most likely it can be modeled with single scattering point. But for a car, it's on the road. It could be near to the transmitter receiver. I mean the base station or the human as the receiver or transmitter is near the road. So in this case, the car is something like it will be modeled by multiple points. So we widely agree this RCS value will be just a scalar, and the effect of target will be modeled as this RCS and also a polarization matrix. For RCS, the high-level principle is we will model this RCS as A times B. So A is something, most likely A is the mean RCS values, which can be included in the large scale for the path loss. And B is something, this is just a scaling factor. It could be included in the small scale. And the B is something most likely could be angular dependent. Yeah. Okay, some more detail about the target channel. So we, after 3 meeting discussion, we make a, I think this is a very key agreement design principle for this one. So we agree to use concatenation-based method to model this target channel. So you can see the figure here. So from TS to target to RS to receiver. So this target. So in general, from run one, we will first model the channel from TS to target. Yeah, there could be loss rate, could be unloss. This unloss could be an unloss cluster or could be some other kind of EO. It's possible. So anyway, this is TS to target link. We model this channel. We model this channel from target to RS. Then finally, we will do concatenation. Here, I just give you an example. This is a case, unlocked array from TS to target can be connected, concatenated with the to the loss array from target to RS. So you can see the parameters for this cluster is statically generated, and also this loss array parameter is determinist generated, and we will concatenate these two together. Yeah. So in general, this is the basic procedure we agreed. So we will also, during this kind of concatenation, we will consider this RCS for this target. This RCS will depending on this incident angle and also this scattered angle. This angle is also used to model the Doppler. So this is the high level, I think, a very key agreement for now. So we will discuss more details in the later meetings. This is the background channel. For this is target channel. For background channel, actually, the progress is not that much. We only agree on some start point to reuse the existing TR. But for TRP, bistatic or monostatic, actually, the current progress in RAMA is we just list some options. So we need to some more discussions in future meetings to down select that solution. Okay, yeah, severe consistency is also one key thing. Is it is mentioned in the seed, but so far because the progress for the target channel, background channel is not that much. So for this issue, we don't spend too much time yet. So finally, maybe in the end of this study, we will also extend the channel model to, currently we focus on the system level simulation channel model, but later we will extend it to the link level channel model. Okay, so basically this is the progress in the current meeting. So we still has, yeah, you know, we had 5 meetings, so there's actually a lot of open issues. Yeah, we need to solve that in the coming meetings. So I just select some key issues here to talk a bit about that. The first one is actually the object modeling. So basically, this is RCS related. So the different targets, different object actually has different shape, different material. The RCS will be quite different. But in general, for UAV, for human, based on some input from the companies, actually, it's observed RCS is almost isotropic. You can see the figure here. This is based on some measurement, also based on retracing calculation. So in general, it looks like it could be a circle on average, but in each direction, there's also some glint. So finally, in the run one, maybe this average value will be modeled as component A. If you still recall what I said per run working assumption here. So basically, you can see, yeah, we model this mean value to the large scale. This glint is likely generated for each ray. Then it's modeled in the small scale. This is UAV and human, and it looks like the RCS is more simpler. But for vehicle, actually, based on some measurement from companies, you can see this. Yes, there's some different direction. Maybe has some peak for the RCS values. So normally for this vehicle, it means in the front, in the end, in the left, in the right, that there's a very high peak for the RCS values. So how to, the exact RCS value is depending on the full discussion. How to capture this kind of RCS pattern into the specification is another story. We need to further discuss on that. Another issue is actually the bistatic RCS. So this formula is or similar formula is discussed by many paper, but based on some input, this is actually not such kind of formula is only accurate if the best uncle is small. So maybe it's possible in the end, in the run one, we have to do some measurement to derive the RCF value for the best ethic. Okay, this is about the target channel design. So I think this is a very key issue. We need to solve that. So then we can know the exact procedure to model this channel modeling. The first one is details for the concatenation. Yeah, for example, assuming this target has a single point, in theory, the correct way should be a kind of convolutional mapping between this tollink TS target and target to RS. However, a simple calculation will show this kind of method is very complicated. So, I mean, the number of rays from TS to target, for example, there are n rays here and n rays the other side. So the total number of rays will be n times n. We need to do some solution to reduce the complexity. It's possible we will drop some paths with some low power, depending on some further discussions. So this is one issue of concatenation. And also we need to know the exact path loss or the power for each path. For example, from TS to target, you can see the red line here. So we need to know how to model the power for this one. So basically, there are two options in the round meetings. So some company propose to model this ray from TS to a target, just assuming the free space transmission. Some others companies, it's proposed actually we can reuse the current path loss calculation formula from the KR 38901. Yeah, we need to do some discussion to do down selection. The current status actually it looks like a majority company want to reuse the current path loss formula from the TR. Yeah, but it depending on some further discussions. And also, this is the polarization. You know, yeah, this from TS to target, there could be some clusters, and the target itself also has some impact for the polarization. And finally, from target to RS, some other clusters or some EOs. So in general, this total polarization effect is the product of these three components. But some company in their preference, they want to do some simplification. So for example, whenever kind of static cluster is modeled, because the polarization for this cluster will be randomly generated after the final product of these three components for the polarization is also kind of a random thing. They want to model this one just using single polarization matrix. So yeah, I mean, I think the final solution is one option is the product of these three components, or we just do simulation to use a simple matrix. Yeah, depending on the further discussion. Issue 4 is actually more clear. So I think now we emphasize this is for the target with single scattering point. It looks like currently most company will prefer to model just single, single loss rate from TS to target and a single loss rate from target to RS, assuming this single scattering point. It looks more reasonable, straightforward. So some other issues I also list here. So we need to discuss how to handle the unlost ray for this modeling, how to handle this target with multiple scattering points, how to handle U type 2, and how to handle whether there's interaction between two targets is allowed or not, the details for the Doppler modeling. So all the things are still open. We already have some proposals, but we still need some time to make the final down selection. Okay, for background channel, I already talked a bit in the previous page. So for background channel for best active mode, currently two options. If we reuse the current TR, but some parameter may be changed based on the validation result submitted by company in the future, or we define some new channel model. This could be a very could be a completely new framework, or could be just reuse the current TR901 framework and try to define new values for the some parameters, but depending on further discussions. For monostatic for background channel, so at least three options is discussed in last August meeting, but some more options are proposed for the coming meeting. So we need to do more discussion to conclude on one option. We also need to do this how to combine this target channel and the background channel, considering power normalization or not. Assuming power normalization is applied, it's possible to make this ISAC channel model similar to the communication channel defined in the previous KR 3901, but it depending on some further discussions. So spatial consistency, we need to do some more work. And also, this is for channel model to prepare for the future performance comparison of the sensing algorithms. We need to do calibration for the channel model. So we will do that in the remaining time. Okay, so this is the work plan. So you can see there are black test and also blue test. So for black test, this could be understood as one milestone. So the current plan is at February next year. So this is 120 meetings for round one. So we plan to try to finish one channel model and also finish the calibration for that. Most likely, this is actually a UAV-related scenario for the channel model. After that, we will do some more work to extend it to the more sensitive target, to the more scenarios, and also for the link level channel modeling, we need to do this kind of extension. So the target finish time will be the June next year. So we will do more work. We still need to do more work to guarantee this channel model could be successfully completed. Okay, so this is the status for the plan for the channel modeling from CTPP. So thank you very much.
Thank you, Yingyang. So as always, if there's questions from the audience, please use the chat. In the meantime, maybe I can start with some questions. So you talk a lot about what's happening in round one. Are there also activities related to ISAC in round two?
So actually, this is for channel model is only in round one.
Sure.
Yeah.
But in round two, there are also activities on ISAC on resource allocation, or you're not aware of them?
Actually, from CGPP, there's for round two work, or even for round one to define some solutions. This kind of work is not started yet.
Mm-hmm. Okay, and in the round one work, I suppose that ISAC is just one of the many things that you are working on, right? In round one.
Yes.
So,
you mean for me, right?
Yeah. So yeah.
Yeah.
So how important is ISAC compared to all the other things in round one? Is it something that's very small, or it's a big thing? How would you evaluate it?
Yeah, I think so. Yeah, if we talk about the TU, so actually this SI work is only one TU. So many other things for memo, for ambient IoT, so they may be allocated for TU. But everyone agree, yeah, even though we have started one TU for now, but this work is very important because we need to do this channel model. It's possible this channel model is also used for 6G discussion, maybe used for for 10 years. So all the company agree. So we need to carefully design this channel model to satisfy the current simulation requirement, and also consider some future possible requirement for that. Yeah.
Thank you. In the meantime, there's two questions from the audience. The first one is, has the work on use cases been concluded?
You mean the use case?
Has the work on use cases been concluded? That's one of the questions from the audience.
The use case is actually I'm not sure if the question is about the scenario.
No, if the work has been concluded, there's no more work on use cases now in run one. That's the question.
Yeah. So we don't discuss use case. Actually, we just refer. You can see this page.
Right.
So we refer these use cases from IC1, but we only focus on the object detection and tracking for now.
Yes.
Yeah.
Good. And then maybe one more quick question. So you talk a lot about the use cases and the channel modeling. What's after that? What is the next activity for round one once the channel modeling is complete?
Okay. So actually, in December this year, we will discuss the 3PP will discuss the work scope for RIS-20 5G Advanced. This is a workshop. I think at that time, company will propose some solution work for sensing in 5G Advanced. In March next year, it is the workshop for 6G. Some companies will propose the potential preference for the ISAC in 6G work scope, and also which kind of feature will be the preference from each company for ISAC. Yeah, in the June next year, the regulatory meeting. So the scope for the RIS-20 for both 5G Advanced and the 6G will be decided. So at that time, we can know the exact scope for the follow-up study for ISAC in 5G Advanced and also 6G.
Yep.
Some solution will be discussed at that time. Yeah.
Perfect. Thank you so much. With that, we're at the end of the presentation. We will move on now to the panel. Thank you again, Yingyang Li, for your presentation.
Yeah.